Hello and welcome to another Science 9 crash course. In this episode, we're going to learn all about the periodic table of the elements. The modern periodic table of the elements is a thing of beauty, but where did it come from? Chemists back in the middle of the 1800s only knew of about 58 different elements, and they wanted to find a way to organize all of these elements. One of these scientists, named Dmitri Mendeleev, tried to organize the elements based on their mass and properties. Mendeleev discovered that elements had similar properties and that they repeated periodically, so he organized them in this manner and created the very first periodic table of the elements. It was so accurate that we still use it today. Mendeleev even predicted the existence of elements that weren't even known in his time but have since been discovered. Now let's take a look at the modern periodic table of the elements and see how it is organized. On the periodic table, each element has its own rectangle that shows its properties. Most modern periodic tables look the same, however you might find some of the information in different locations or different corners of the rectangle. But usually starting at the top you have the element name. Following the name you have the atomic number. The atomic number is simply the number of protons in the nucleus of the atom. And of course below that you have the symbol for the element. And lastly at the bottom you have the atomic mass. This is the average mass of the atoms in an element. Another piece of information that isn't found on the periodic table but can easily be determined is the mass number. To calculate the mass number, all you have to do is add up the total number of protons and neutrons in the nucleus of the atom. You can also use this formula to calculate the number of neutrons in the atom by subtracting the number of protons off of the mass number. For example, if I had the element carbon, and the mass number is 12, I would subtract off 6 because that is the number of protons, which is equal to the atomic number, which would give me a total of 6 neutrons in the nucleus. The periodic table can also be organized in a couple different ways. Firstly, it can be organized into vertical columns called groups. On the periodic table there are 18 groups, and each group has elements that share similar chemical properties. The reason why these elements in these groups have similar properties is because they have similar electron arrangements. Electrons can reside in different electron shells or energy levels. And these energy levels can only hold a certain number of electrons. For example, the first energy level can only hold 2, and the second energy level can only hold up to a maximum of 8. So if you notice in group 1, hydrogen, lithium, and sodium all have different numbers of electrons, but all have 1 electron in their outermost energy level. And of course, because of this, they share similar chemical properties. The periodic table is also organized in another way. It is organized into periods, which are horizontal rows. There are 7 periods in the periodic table, and each period represents a different electron energy level. So for example, the first energy level, as I said, can only hold up to 2 electrons. So hydrogen and helium's electrons take up these spots. And once that energy level is full, we have to move down to period number 2 and start filling in that energy level, which can hold up to 8. And here's a picture that shows each element's electron arrangement in each electron shell. You may want to pause it and take a closer look. Well, I hope that you find the periodic table as cool and as interesting as I do, but the crash course has now come to an end, so thanks for listening.